Hello, Assalamu alaikum. My name is Asad Ikram, and today I will be talking about this particular problem set of restaurant clusters. So, basically, what we are going to do is that this is the problem that we have chosen. We are going to perform the data exploration analysis to find the zones of new restaurants in Pittsburgh, PA. So, first of all, what we have to do is that we are going to use the density based clustering in using the ArcGIS. So first of all, we are going to extract the current status, retrieve the Pittsburgh restaurants data, and then we are going to uh, present the data using the ArcGIS in form of maps, in form of charts, in form of tables. Then we are going to perform spatial analysis based on the density based clustering, directional distribution, and then we are going to prioritize that restaurant zones based on the sales volumes and based on the hotspots. So the general flow will be like this. We are going to get the Pittsburgh restaurants GIS data. We are going to perform density based clustering on it, and we have the clustered restaurants. Then on those clustered restaurants, we will have the standard deviational ellipses, and we will make the cluster zones based on that. And those cluster zones will have the sales volume aggregation. Let's suppose we have a particular zone with more sales, we have another zone with less sales. So we will make an optimized zone, you can say, and with additional score distributor, we will calculate the priority scores. So each zone will have a priority score with it, which zone is more important, which zone is less important, and then we will report that cluster zones with the project scores. We will display that. So this will enable us to you can say target where we should make our new restaurants. As you have seen the general market perceptions, you have seen that we make the restaurants in the places where other restaurants are running already. So why we do that is that because that market spot, that spot right there, is a hot spot, and it means that we have a lot of customers there. So those lots of customer will be interested in trying the new things that our restaurant is going to provide. So this is why we use the help of the ArcGIS, uh, which gives us the locations but we wanted. All right. So these are the necessary modules that we will be needing. We will be needing the NumPy libraries. Obviously, we are going to use the pandas. We have the OS, we have the time, we have the legends, and using the ArcGIS libraries, this is the Booker resources. We are going to use CDN, cluster distribution network, and the ArcGIS we will be using features. We will be using geo accessors, geo enrichment. We're going to use geometry as well. Moving on, first we will create the map and histogram of our locations. So we'll be creating the map. We'll be creating the layers. We will be adding colors to it. We're going to use the histogram of the sales volume and add colors. So this is basically what we are making up the map, the web map, based on the visit sites and based on the visit ellipsis features. So first of all, we will retrieve the Pittsburgh data, and it will be added to the add tool in the ArcGIS. We will add on the Pittsburgh restaurant data, and this is how our data should look like. We have the shapes, we have the city name, we have the name of we have the employee numbers, we have the ISO code, We have location, location number, we have the NAICS, we have source, we have state, state number, status, street, etc. So customer name, we have the you can say data for the customers. We have around 5 rows and 22 columns in it. So what we are going to do is that we are going to store this um, temporarily store this specially enabled data frame as a feature class in the ArcPy, so we can use it later. So we will explore the data through the tables and charts and maps. So we will have the amount of the restaurants, we have the amount of the attributes that we're going to have, and if we look at our restaurant data frame, we will have the employee number of each restaurant, we have the sales volume, we will have the score, and the score will be based on the current rating that it has in the market. So we have a good idea of which restaurant is having what type of score. So this is the summary statistics of the data frame. We have the count, mean, etc. of each attribute. So if we map the Pittsburgh, the map is going to look like this. These are the restaurants that you can see on the map. And as we can see, they're distributed. Some have some are very concentrated at some places. Some are scattered as well. So yeah, and this is the data based on symbolized by the sales volume. So as you can see that this is how it looks like. So first we will find out what are the top 5 restaurants in it. Top 5 restaurant Pittsburghs by sales volume. These are the top 5 ones with the maximum to minimum sales volume. Top 5 ones. And as you can see on the map, these are the top 5 restaurants that we have um, taken using the data frame. And we will also find out the top 5 zip codes by the sales volume. So we know which zones has the more sales, which zip codes have the more sales. So as you can see that these are the top 5 ones according to the zip code we have. And that's the data for the Pennsylvania. So you can see that these are the top 5 zip codes that we were talking about. And these are the ones that are you can even say the gray ones on the right side as well, but we have made a boundary here. And these are the zip codes that has more restaurants in it, which has more sales in it according to the sales volume. So what we are going to do is that we are going to now perform a spatial analysis on this particular map, and using the density based clustering we are going to make a few clusters. So we have defined distance, dB scan, we have self-adjusting HDB scans, we have multi-scale as well as optics. So based on this, we are going to perform the HDB scan on it, and which uses a range of distances to separate clusters of varying distance densities from sparser noises. The HDBS scan algorithm is the most driven of the clustering methods, and thus requires the least user input. All right. As we know that we have not a very large amount of data, and but we do have a kind of a data um, which is indicating some kind of information which has some kind of a value in it. Each data point is valid. So we are going to use this algorithm on our data set, and if we visualize our result set for both the clusters and the noises, so this is how it is going to look like. And if you only visualize the clusters, it will be like this. We will